Okay, I got a lot of good feedback on your understanding of the entity relationship diagram, specifically about cardinality and foreign keys. So I think there's some maybe confusion about when a primary key becomes a foreign key and how that works. And so I'd like to go through an example that has actual data so that you can sort of understand a little bit better why we model things the way that we do. And I think going through another example will also help. So I definitely recommend going through as many examples as you can and all the examples that I'll provide in order to kind of understand what's going on. So when I was an undergraduate student, we had what was called a May term course. And so that was a course that was offered in May that was just a month, and you could take just one course that May. You didn't have to take a course. And in order for the course to run, it had to have at least one student. And so before looking at what an ERD of that would look like, although you can probably imagine, here is a set of data that reflects this situation. So if you take a look at the table, you can see that there are basically two entities represented here. We have student information, so the student ID, the student first name, and the student last name. And then we have course information, so we have a course number and a course name. And they're mixed in the same table. And we had talked about some different data issues. I think what jumps out is that we have a lot of repeated information here. So you can see it's each time we have a new student, the course information is repeated. And so we have this 100 minerals repeated as many times as there are instances of students. And so I'll let that sink in for a minute. And so if you're kind of thinking about what type of cardinality this might be, if you look at it long enough, you can start to see that this is a one-to-many relationship. So we have a case where students are taking at most one course. The course can have many students, so we have a one-to-many case. And you can see that when we combine the data, that we have repeated information. So what I'd like to do next is show you what happens when we start to what's called normalize the data. So we're not going to get to normalization for a little while, but it's a topic that's going to come up in the course. And so let's take a look at what that starts to look like. So in other words, I'm separating the student information from the course information. So now I have two tables. It's the same situation, but here I have just a table with all, 45 students. And then I have the three courses that those students can be enrolled in. And here you can see the ERD. So we have, I'll kind of do the demonstration again, but basically, if I take the case of one course, so an instance of a course like 100 minerals, and I'm asking myself, well, what's the maximum number of students that can be enrolled in that course? Well, that's going to be many. So notice the crow's feet are on this side. So for a particular course, what's the maximum number of students? Well, that's many. And similarly, if I'm on the student side for a single student like Sally Jones, what's the maximum number of courses that they can take? Well, it's May term, and the rule is that they can only be enrolled in a maximum of one course. So I put the mark on here. But I also put the circle here to indicate that a particular student does not have to be enrolled in the course. So they'll just be in the system regardless. Okay, but if we take a look at the tables, right now the tables aren't related. We know that we have a relationship here, that students will take courses courses will have students enrolled in them. But the purpose of representing the relationship is basically so that when we're doing a query, which we'll do later, I could say something like, well, given a particular student ID, can I find, the name of the course that the student's enrolled in? Or if I'm given a student last name, can I look up the course name that's related? So what I have to do is use the foreign key to get from one table to the other. So we talked about in last class the rule for a one-to-many relationship. That basically the primary key on the one side becomes a foreign key on the many side. So in this case, we know just by the rule that the course number is going to go into the student entity as a foreign key, which would also mean that if we looked at the table, we would put the course number in the table to show which course the student was enrolled in. Because notice, if you kind of getting back to the fact that we have the relationship, but that the tables aren't representing it yet. The tables do not show the actual relationship. I don't know if I look at the student table, I can't tell who's enrolled in what course because I don't have the foreign key in yet. So we talked about the rule, but what I want to do is show you what would happen if we set it up the other way. So I want to show you what happens if we try to take the student ID and make it the foreign key. So what we're going to do is, in order to represent that, show what the tables would look like either way. If we took the student ID and put it in the course table, or the course number and put that in the student table. So let's first look at the correct version. So let's first look at what happens if we follow the rule. We do the one goes to the many side. So what we have here is we've taken the course number and we've added it to the student table. It's now a foreign key. And so on the ERD, I'd represent that over here. Now the question is, do we have repeated information? We certainly see the same course number multiple times. So I see that I have the course number 100 quite a few times, but it's only repeated information if the record itself, in other words, the entire row, is repeated. So as long as the entire record is unique, then we don't actually have any redundancy. All this is representing is the fact that all the 15 of these students are enrolled in this course. And it looks quite nice and neat. So now if I look up a particular student, like Timothy Green here, I can tell right away which course he's enrolled in. And if I wanted to know the name of the course, I could then say, okay, well, he's enrolled in course 100. I go to the course table, I look at 100, and the course name is Minerals. So we can see how that works. Let's take a look at what happens if we decide to go the other way, if we put the student ID in the course table. Because again, the reason that we're using the primary key as a foreign key is to be able to actually show the relationship between the student and the course table. This is what would happen if we put the student ID as a foreign key in the course table. You can see that we have the course information, and then in order to represent all of the students that are enrolled in the course, I have to repeat course number, course name 15 times for that first course. So you can see that 100 is the primary key, and I'm repeating that course name all 15 times to represent, to be able to show that each of those 15 students is in there. Now, it might take a little bit of time for this to sink in exactly what the difference is, but if you keep in mind the idea that we want unique records, unique instances, that should help So I recommend kind of toying with this example to really feel out what the difference is. And hopefully it starts to make a little bit more sense. So I just want to show the correct example one more time. You can see that I have a representation of all 15 students enrolled in Course 100, and I have not repeated any of the student information. This course number is not considered to be a repeat because it's uniquely identifying every single student that's enrolled in the course. As opposed to, if I again look at this example, I have a representation of all 15 students in the course, but while I'm doing that, I'm repeating the course name over and over again, which is just taking up additional space that I don't need to be taking up in the database.